Hello, in this video I just want to give you a brief review of the production possibilities frontier, and I want to introduce a new concept that's related to the PPF, which is the unit factor requirement. Alright, so first of all, as you probably remember, the PPF, the production possibilities frontier, shows all combinations of two goods that can be produced by or in an economy given its resources and technology. And when we say resources, we're thinking here labor, capital, land. Another names for a resource is input or a factor of production. Technology is anything that transform resources or input into goods or output. So, we can think of it as a black box here, where you put input into this box and then technology somehow turns that into output. So that's what we have in mind when we think about a production possibilities frontier, resources and technology. All right, so one new thing that we usually don't see in other courses is the unit factor requirement. A unit factor requirement is a concept that makes it easy for us to express technology. And the unit factor requirement tells us how many units of a factor of production that are required to produce 1 unit of output. So here we have an example, A. So we're going to call this unit factor requirement this little a. And this is the unit labor requirement because it's the A subscript L X. And that's equal to 10. So what that means, and this is important, it takes 10 units of factor L to produce 1 unit of good X. So this is what that's going to mean. ALX equals 10. All right, so when we think about a PPF, you probably are familiar with it. So let me just write we have two kinds. So first of all, we always have two goods on the two axes. So let's call this good A and good B. And I'm going to do that for both of these diagrams here. So the first case is when we have a single resource. So for example, we only have labor. If you have a single resource, then your PPF is going to be a straight line. It's going to look something like this. If you have more than one resource, such as capital and labor, or you have skilled labor and unskilled labor, then you will have a PPF that has a concave shape. So it's going to look something like this. In this course, in international trade, we use both of these, but in the beginning, we tend to focus on a straight line PPF because we're going to just assume that we have one factor of production, say labor. So, okay, so this is where we are, and what we next need to figure out is how is this PPF actually drawn? So, how do we determine what the intercepts are, and how do we determine the slope of this PPF? All right, so that's what I want to do here. When we have, so when we have a PPF, we have to determine what the intercepts, the slopes are, and we also want to talk about what the shifts, or what a shift in a PPF means, or what would actually shift a PPF. So the first thing we're going to be doing here is we are once again looking at this case when we have two goods, A and B, and we have some resource. So my resource in this example here is going to be labor. And we're going to denote that L. And then we're going to have some technology. And the technology is going to be described by our unit labor requirements. So we're going to have a unit labor requirement for good A and a unit labor requirement for good B. All right, if we have this, then to find the intercept, so if we want to figure out how many of good A will we be able to produce if we don't produce any of good B, then we take the total amount of resources that we have, L, and divide it by the unit labor requirement for good A. So the intuition here is that the unit labor requirement tells us how many units of L is required to produce 1 unit of A. So if you divide the total number of workers that you have with the number of workers is required to produce 1 unit of A, you will get the number of good A that you could possibly produce. All right, so this here is going to give us a point over here. I'm just going to write this right there. So this is the maximum amount of A we could produce. And of course, if we produce that many good A, then we will be producing 0 of good B. Similarly, if we want to figure out how many of good B we can produce, we would take the number of resources and then divide by the unit labor requirement for good B. And the same reason, ALB here tells us how many units of labor is required to produce 1 unit of good B. And if you divide that, or if you take the total number of labor and divide it by the unit labor requirement for good B, you will figure out how many of good B you can possibly produce. So that will be a point on this axis, and I'm going to denote that like this. And then we have to figure out, of course, if we only have labor, we know it's going to be a straight line PPF, so I can actually draw that in here. It's just a straight line. But let's try to figure out the slope of this line. So we want to figure out the slope. Well, the slope is, of course, rise over run, or the change in QB divided by change in QA. And when we have this one here, we can see that the change in QB is just L divided by ALB minus 0. So we have L divided by ALB minus 0 if we want, but that's just going to go away, of course. And the run is going to be L divided by ALA minus 0. And if we just simplify this, you can easily see that it's going to be ALA divided by ALB. So the slope of our PPF is going to be the ratio of the unit labor requirement. And this slope actually has a interpretation, because this slope here is the opportunity cost. So let me just write that. So what it is it tells us how many units of good B you have to give up in order to produce good A. So this is the opportunity cost of the good on the horizontal axis here. So often we will write this as OCA equal, some number of B. And that number of B, let me just make sure we're very careful here. And that number of good B is going to be equal to ALA divided by ALB units of B. So let me just write, that's the units here. All right, so that's what, when we want to draw it, this is what we're going to be doing. Let me just say one more thing. So when you have this PPF, you have, of course, it's possible to produce points inside of the PPF. So all these points over here are possible, but they're not optimal, because that would mean that you're not using all of your resources efficiently. So points or production possibilities inside a PPF is possible, but not efficient. At the same time, points outside of the PPF is not possible, because we don't have enough resources, or our technology is not good enough to reach those levels of output of A and B. And then, of course, we have points on the PPF. And when you're on the PPF, then you're using all your resources efficiently. That is, you're using all your resources, labor, and you're using the best technology, ALA and ALB, and this is where you want to be. You're not wasting resources, you're doing as well as you possibly can. Of course, any point on the PPF is possible. So a question will be, where on the PPF would you like to be? But that's a question we're going to address a little bit later. All right, so just one more thing before we move on to an example, and that is, what will shift the PPF? Well, you can see that anything that would make these intercepts either increase or decrease or change in some way would shift the PPF. So in general, there are two things that can shift the PPF. You can either have a change in resources or you can have a change in technology. So in our example, you can either change the number of workers, or you can change either ALA or change ALB, or of course both. So this would be what would change our PPF. All right, let's do an example here. So the way I've set it up here, I'm going to suppose that we have 100 units of labor. And the unit labor requirement for good A is 2, so it takes 2 units of L to produce 1 unit of A. And the unit labor requirement for good B is 4, so it takes 4 units of L to produce 1 unit of B. So the first thing we want to do is, of course, draw the PPF. So here again, I'm going to write QA here and QB. And we know that the maximum amount of QA we can produce is to take L and divide it by the unit labor requirement for A. So that's going to be 100 divided by 2 equals 50. So this is called 50 right there. And if you're going to find the maximum amount of a good that of the good B that we can produce, we take the total number of resources, 100, and divide it by unit labor requirement, and that's 25. So here's 25. And then the PPF will be drawn as a straight line between those 2 points. Of course, we want to find the slope, because the slope has an interpretation, that's the opportunity cost. So we know that the slope, which is equal to the opportunity cost of good A, is going to be the ratio of ALA to ALB. So in this case, that's going to be 2 divided by 4 equals 0.5. And the unit is number of B. So what this means is to produce 1 unit of good A, we would have to give up half a unit of good B. So the intuition here is that if this economy wants to produce 1 more unit of good A, it would have to forego or give up the production of 0.5 units of good B. All right, so what if we want to think about a shift here? So if we have more resources, suppose I told you that we now have 200 workers. Clearly you can see that the total number of workers increasing like this would allow us to produce now 100 units of A. So, we would shift this out. I would have to make it a little bit further out. And the total number of B is going to be 200 divided by 4, which is equal to 50. So we're going to have 50 over here. So if you have twice as much resources, we're just going to shift out the PPF like that. And of course, you notice that the slope, because I didn't change the technology, the slope is still equal to 0.5. So this is going to be a parallel shift. Another thing that would shift the PPF would be if we change the technology. Right? So we can change either ALA or ALB. Let's change ALB from 4 to 2. Then, of course, we know that QA, let's suppose that L is once again equal to 100. Then quantity of good A is still 50. But the quantity of good B, if we make workers twice as productive in the production of good B, so it takes 2 workers instead of 4, then we can produce 50 units of good B. And that, of course, would make our new PPF have a slope that is steeper. In fact, we can find what the slope is. Slope is now equal to ALA equals divided by ALB, which is 2 divided by 2, 1B. Or I shouldn't say 1B yet. I would have to rewrite that. So the slope is equal to the opportunity cost of A, which is now equal to 1B. You would have to give up 1B to produce one more of good A. All right, very good. Maybe I'll just say one more thing. If I told you that we are producing, say, 25 units of good A, you can tell me how many units of good B that we could possibly produce. So if QA equals 25, that means we are using how many units of labor is going into the production of good A? Well, every unit produced requires the unit labor requirement, ALA, and ALA is equal to 2, so that will be 50. So if we're producing 25 units of good A, we're using 50 of our units of labor, which means that we can devote 50 workers to the production of good B, which means that good B would be equal to 12.5. And again, of course, I went back to using our original numbers. So again, when you look at these numbers, the L represents resources and the 2 A's represents technology. All right, so that's really all we need to know about the PPF. The next question will be, where on the PPF should we or would the economy want to be? And that will depend on consumers' preferences.